wanted to talk to you today about this tool that we've been building for about the last 4 years. It really is intended to be a scenario testing tool. It's being able to look at future scenarios for different types of commodities and understand their implications for the transportation network and transportation patterns and flows. It optimizes the routing at and flows at the scenario level. It's got two components, a GIS module and an optimization module. And its foundation is a multimodal network that the GIS team here at Volpe has put together, which covers road, rail, waterway, pipeline, and a set of intermodal facilities that connect those modes. The way this tool works, as I said, it has this GIS module, Geographic Information System module. That's the geospatial element. That's what allows us to look at how things actually flow over the transportation system. We feed in our scenario file, which is all our parameters about costs and different factors that we want to put into the model. And we feed in a bunch of network layers for road, rail, waterway, pipeline. The GIS tool, we have a network builder that knits that all together into multimodal network. And then it generates our route options among the origins and destinations that we've put in there. Then it has to pass it over to the optimizer. So there's what we call a handshake, where that optimizer wants that information on a commodity-specific basis. So the GIS says, give me some route, or here are your routes. The handshake says, now let's split those out by commodity and time so we know what we have, and they're all separated out, and we can track them individually and assign flows to them. Then the optimizer says, okay, where's all this stuff going to go? How much is going to go where? What makes sense? And then we generate that optimal solution. It transfers that back to the GIS, and that's where we get our reports and our mapping. In the case of the work we're doing with FAA, we really want to understand how much alternative jet fuel can we get in the near term. And so we've decided to do this analysis looking specifically at waste feedstocks and residues. So when we talk about residues, we're talking about things like corn stover, corn stalks and cobs, or woody residues, things slash that's left after harvesting of timber. And then we're also looking at tallow from slaughterhouses and municipal solid waste. And we've projected this out to 2030 to look at expected availability and be able to look at how we expect that material to flow over the system, given the processes for producing alternative jet fuel that are already qualified through ASTM. So you can't just decide something's jet fuel and stick it in a plane and fly. There's a certification process that's quite rigorous to allow those fuels to fly. And right now we have 5 processes, or 5 different annexes that allow alternative jet fuel into the fuel pool. And here we're analyzing 3 of them that we expect to be dominant in the near term in the US. With Department of Energy's Energy Policy and Systems Analysis Group, we're focused much more on fossil energy, and we're looking at crude oil and coal scenarios. They have been working with Oak Ridge National Lab to translate the commodity flow survey down to the county level. So they're looking at county-to-county flows of crude oil and coal. And they actually, in many cases, know what mode that material is moving over from county to county, or at least the primary mode. So what we've been doing is mapping those data in our network, identifying the paths that it could take based on those modal constraints when we know them, and the FTOT routing algorithms. Then what we can do is we can turn those data into origin and destination information. The way we like to think of this is kind of your best case scenario. If you had the perfect system in place for your future scenario, what would this look like? And one way this has been really valuable is in life cycle analysis, looking at particularly emissions, greenhouse gases, and other things, because a lot of times we want to know, well, what's the contribution of something like transportation to that? And giving a best case scenario in that instance helps people understand, whether or not this is a viable or valuable approach.